Very cool. So today we're going to be learning how to graph equations by hand, and there are two things you need in order to graph something. You need a slope and you need a y-intercept. So go ahead and take your highlighter, and I want you to highlight slope and y-intercept. Those are the two things that you need to know in order to graph. You need to know what the slope is, and you need to know what the y-intercept is. Now, luckily, we've been learning that our equations tell us both of those things right off the bat. It's going to tell you the slope and the y-intercept from the equation. So let's look at example number 1. This is what we're going to try to graph. Y equals 1/2 x minus 3. And this equation has a very specific graph that goes with it, and we're going to show you that today. Now, before we move on, I want us to identify what the slope and y-intercept are. So underneath this, can everyone please write the following? Y equals mx plus b. This is your generic equation. Y equals mx plus b, where m and b are separated, and they each have numbers associated with them. Y and x are going to stay a variable. So let's go ahead and identify what we have. M is going to be your slope. M equals. B is going to be your y-intercept. B equals. So let's go ahead and see which one's which. Who remembers from yesterday, which of these numbers is going to be your slope? Which one is m? Just say it out loud. 1/2. So let's put m equals 1/2. And which one is your y-intercept? -3. Very good. Remember, the y-intercept is technically plus b. So if it says minus a number, that means your y-intercept is negative. Now that we've identified both of those, let's talk about why that's important. Go back up to your instructions. This is why I really love this note page, because if you're a person who typically hates math because there's a lot of rules, I literally typed out the steps for you. 1, 2, and 3. So go ahead and take your highlighter, and we're going to talk about step 1. Step 1 when graphing a line by hand is to always start with the y-intercept. Your y-intercept is always going to be your starting point because it's going to just be one dot on the y-axis. Y-intercept means it's going to cross which axis? The y-axis. Now, if I give you a graph, I have to give you the y-axis, which is why it's always good to start at that dot. All right, so let's go down here and let's do our first step. Keep your highlighter in your hand, and I want us to highlight which number we're going to start with, which is B, our y-intercept. Bubble that in. After that, go ahead and pick up your pencil again, and let's talk about where that dot's going to go. We're going to look at the y-axis, which is this line down the middle. Can everyone label that y-axis? You are just going to put a dot somewhere on this axis, but specifically at -3, since that's what the equation says. Everyone find -3 with their pencil, which is right here. And I want you to make a big dot. That is where we're going to start from. Good so far? Okay. After you graph your y-intercept, you need a few more dots to actually make a line. So right now, we know our line's going to start from here, but is it going to go up? And is it going to go up by how much, how little, etc., etc.? That's where step 2 comes into play. Pick up your highlighter again, and let's highlight the important stuff from step 2. Step 2 says you're going to use the slope to plot at least 2 more points. At least 2 more points. Now, here's the reason that slope is important. Slope is being multiplied, and if something's being multiplied, we can use it multiple times again. Now, slope is always needing to be a fraction, and that's because it gives you a rise, how far up and down you go, and it gives you a run. So as a fraction, you always have a rise, and you'll have a run. Remember, the top number tells you if you're going to go up or down. That's your rise. What does your run tell you? Which direction does your run tell you? Left or right. Thank you. So let's remind ourselves, slope is always a fraction because in order to plot the rest of our points, you need a rise and you need to run. How far up and down do you go? How far left and right do you go? You need both of those numbers. Okay? So let's go down here. Let's look at example number 1. Our slope is 1/2. Is our slope positive or is it negative? It's positive. That means both of your actions need to be positive as well. If our rise is a 1, which direction would be positive, up or down? Up. So next to 1, can everyone write the word up? You're going to go up 1. Now you have a run of 2. If you have to run 2 spaces, but it's positive, are you going to go left or right? Right. So up and right is positive, down and left are negative actions. So keep that in mind. Alrighty. So now we're going to start from our starting dot, and we are going to follow this slope pattern. We're going to go up 1, right 2, up 1, right 2. So everyone take their pencil. We're going to start from your y-intercept, and we are going to make count loop-de-loops up 1 over 2. So watch and then repeat. Ready? Up 1 over 2. 1, 2, put a dot right there. So I started from the y-intercept. I go up 1 over 2, put a dot right there. Rise over run. All right, let's do that again. From this new dot you made, you're going to just keep continuing to do slope because slope is a repeat pattern. So from the dot you just made, you're going to keep doing slope. Up 1 over 2, 1, 2, put a dot right there. So if you can see the pattern, I'm literally jumping up 1 space and right 2. Up 1 space, right 2. Now I can't go more than that because I would go off the grid, but luckily I need only 3 dots. Your starting dot and 2 more dots. So at the top of your paper, can everyone write at least 3 dots in total? Now, the word at least is important because the more dots you make, the more accurate your line is going to be. So on tomorrow's activity, if you aren't getting the right answer, you might need to take more dots in order to make your line more accurate. The more dots, the better, but I am making sure you need how many dots at least? 3. That is the minimum. Without 3, you can't really tell what the line is doing. Now, once you have 3 dots, you move on to step 3. Draw a straight line through all of the points. Next to this, can everyone put in big capital letters? Ruler. Ruler. These are straight lines, and for that reason, you need a ruler in order to make it look very, very straight, which is why you should have one on your desk. Go ahead and take your ruler, and I want you to line it up with the 3 dots that you made to the best of your ability. Line it up super, super well. As best as you can. And then you are going to put a big line through the whole thing. Notice that Miss Garrison's line goes all the way across the graph, and that's what I want to see, because technically this line is going to go on forever and ever and ever. We're just not drawing all the dots. We're only drawing 3. So we need to show someone that it goes on forever, which is why I'm going to put arrows at the end as well. If you could add arrows at the end, that would also be great. All right, to graph a line, you start with the y-intercept, you put a dot where that y-intercept is, and then you use your slope to graph at least 2 more points, but the more the merrier. Is this making sense so far? Cool. Any questions? Awesome. Let's go on to example 2. It's going to bring up a question probably. On example 2, the first thing I want from us is to identify the slope and the y-intercept. So we have slope is m, and the y-intercept is b. M and b. All right, looking at this equation, y equals 3x plus 1. Can someone raise their hand? Which of these numbers is m, or the slope? Diago. 3. And which of these numbers is y-intercept, or the b? Yep, 1. Now it is a positive 1, so keep that in mind. All right, now that we know all those things, I want you to pick up your highlighter, because according to step number 1, we always start with the y-intercept. So we're going to highlight the y-intercept. We're going to start by using positive 1. To figure out, bless you, to figure out where this is going to go, you're going to look at the y-axis, which is this one right here. And somewhere on that y-axis, you're going to have a starting point. And the starting point is specifically going to be at positive 1. So everyone take their pencil, and I want you to put a big dot on positive 1 on the y-axis right there. That is going to be your starting dot. Chance, do you get this written? Cool. That is going to be your starting dot. Okay, now here's where the what if comes into play. To get the rest of your dots, you're going to use the slope because it gives you a rise and a run. But here's our first problem, friends. I only have one number. Is this a fraction? No. So we have to make it into a fraction, which honestly is pretty easy if you remember your division rules. The whole number is going to be the numerator. Does anyone know what a denominator of a whole number would be? Like, what could I put at the bottom to keep it a 3? 1. Everyone put a 1 at the bottom. That is something you have to know in order to do slope. You need a rise and you need a run, which is why we're keeping everything as a fraction, because you need to know how far up you go and how far right you go. A rise and a run. Is this making sense so far? Awesome. Now that we know our slope, since our slope is positive, we're going to go up and to the right since it's positive and positive. Positive, positive. So let's start from our y-intercept, and we're going to go rise 3, 1, 2, 3, run 1, run 1, put a dot right there. I'm going to do that again. Rise 3, 1, 2, 3, run 1, put a dot right there. Now here's our next problem. Can Miss Garrison go up 3 anymore? No. So here's our problem. Go up here. So I put some notations for you that might help you out, so let's talk about it. If you have a positive slope, you can go up and to the right, because up and right is positive and positive. Or you could go which way? Down and left. Everyone bubble that in. And let's talk about why this works. So down and left are both negative actions. So let's go over here off to the side, and I'm going to show you why this works super, super quickly. So instead of positive 3 and positive 1, we would have negative 3 and negative 1 as our slope. Now, what happens in a fraction if you have a negative on top and bottom? They cancel out. So if you run out of room and can't go up and right, you can go backwards, which is down is negative, and left, which is also negative. So here's what we're going to do. I want you to go back to your starting point, which is at positive 1. And instead of up and right, you're going to go backwards, down and left. You still use the same numbers, down 3 over 1, but you're just going the opposite direction since you ran out of room. So everyone put their pencil on their starting dot. I want to see it. And we're going to do rise over run, but we're going to go backwards. Ready? Down 3, 1, 2, 3, run 1, backwards, put a dot right there. And you can actually make another dot if you want to. You can keep going. Down 3, 1, 2, 3, run left, put a dot right there. So in orange is showing you an opposite way to go if you run out of room. You can go up and right if it's positive, or you can go down and left since the negatives would cancel out, making it positive anyways. How many dots do you need at minimum? 3. Do we have at least 3? Perfect. We have 4, which is even better. That's going to make our line more exact. So once we have at least 3 dots, you're going to take your handy dandy ruler. You're going to plop that bad boy down on your paper. And you're going to take your time to line it up to the best of your ability. You're going to take your little pencil, lining it up super, super carefully, like you're an artist. You're going to draw a line all through those dots, connecting them. We're going to put arrows at the end to show someone that this line does technically go on forever. We're just too lazy to make it go on forever. So that's what the arrows are for. Alrighty. To recap, you start with your y-intercept to get 1 dot. You start from that dot and then use your slope to do rise over run to find at least 2 more points, and then you connect the lines. I want to see how well you're catching on to this, but I only want you to do A. Don't go on to B because that brings up another situation. I just want you and your group to try to graph A. I'm going to set a timer for 4 minutes, and then you should be done. Okay? Go. 4-minute timer. What is your 7th period? 7th? Fine. What? With who? I might write you a note. Yes, you're working with your group.
Please take me out. They give me a headache every day.
I might ask you to come for, oh, she did great, I'm all good. I might ask you to come for a little bit because I need to go.
Yeah, this was nice.
I'm going to upload this to YouTube.
The teammates over there.
I'm going to need the sub to play it, but it might need help. So I might have you come in for 10 minutes and help them. So I'll show you what it's going to look like.
Please take me out.
I'm going to write you. You're talking with your group. You're working on A. You have 2.5 minutes. Let's stand over here.
Do you need help? Oh. Yo, kids. Yeah, your bus is here. I do.
Is over here. So maybe this halfway, and this is like up and down, depending. Okay, you got 1 minute. I know.
So do I play this first?
Oh, yeah. My room is 224. So I'll leave my code on here. All right, you got 4 seconds. 2, 1. Sweet. Okay. Let's see who has been paying attention so far. So, can someone raise their hand? If our equation is y equals 2/3 x minus 1, what is our m and what is our b? Can someone raise their hand? Which one is our slope? Which number? Braylon?
2/3.
It's going to be 2/3. Very good. Positive and positive. So up and to the right is one way we can go. Chance, what's my y-intercept?
Huh? Oh, it's a -1.
-1. Very good. I love how he said -1 because remember there's a minus in front of it. Very good. So which one do we always start with? Jinsey, which number are we going to start with? The slope or the y-intercept? Okay, look at the top at your instructions. Oh, that's okay. Charisma, which one are we going to start with?
The y-intercept.
You can repeat it. Perfect. So we're going to start with the y-intercept. That's always going to be our starting point. So if you didn't do so, take your highlighter and I want you to bubble in the y-intercept. That's always what you're going to start from, is the y-intercept. So our y-intercept is -1. So we're going to look at the y-axis. And on the y-axis, we're going to put a big dot on -1. Boom. Once you have a dot on -1, you're going to use your slope to graph at least 2 more points. Since our slope is positive, starting from our starting point, we need to go up and right. Up 2, running 3, since it's 2 over 3. So we're going to count together, and we're counting our spaces. Up 2, 1, 2, run 3, 1, 2, 3, put a dot right there. Now, you could go up 2 again, but you would run out of room if you went over 3. The dot would be somewhere over here, but it's not quite on our graph. So if we can't go up and to the right, I go down, and which way? To the left. I need to go backwards. Down and to the left, because both of these are technically positive. So I'm going to go back to my starting dot, and instead of up and right, I'm going to go down and left. Down 2, 1, 2, left 3, 1, 2, 3, put a dot right there. Now remember, you only need 3 dots at minimum to graph your line. Once you have at least 3 solid dots, you're going to take your ruler. Hopefully you did. You're going to take your ruler, you're going to line up all 3 of those dots. So make sure you have them where I placed them. And you are going to put a big line all the way through your graph. The entire thing. What do we put at the end of our line, though? Arrows. Arrows to show that it doesn't end. Okay, we are almost done, but Jency, I'm going to need everyone to pay attention because it's our last question, Theseus, and this is kind of a hard one. On question B, the first thing we're going to do, as always, is figure out the y-intercept, and we're going to figure out the slope, which is m. Let's go with Crystal. Crystal, what number is our y-intercept? -3, very good. And Karan, which number is our slope? Yep, -3 or -3x. So they're both -3. But I want you to take your highlighter, and I want you to specifically highlight B. Because B is always going to be our starting point, because B is our y-intercept. Our y-intercept is easy to graph because it's always going to be on the y-axis, and it's just wherever the number lies on the y-axis. For example, since mine is -3, I'm just going to go to the y-axis and put a dot on -3. No coordinates, no thinking about it. It's just a dot on the y. Now, Chance, who's sitting up, once you have a starting point, you're going to use your slope to find the rest of the numbers. But we run into our problem again. I only have a rise, and I don't have a run. Can someone remember, how do I make a whole number into a fraction? What am I going to put on bottom, Braylon? The 1. Now, here is our problem. Look at my starting point.
Wait, where do you get the 1?
So all whole numbers have an invisible denominator of 1. We just don't put it there because -3 divided by 1 simplifies to -3. However, in order to graph slope, we do need a denominator since we need a run. Great question. Now, if you have been zoning out, I need you to look at the board because this is important. Since the top is negative and the bottom is positive, technically this fraction is telling you to go down 3, right 1. Down and right. But watch what happens. Can you go down 3? You run out of room. So everyone go back up to your cheat sheet. If your slope is negative and you can't go down and right, what is the other way you could go? Everyone bubble that in. Up and left. Very good. So we're going to go back to our original dot. I'm going to show you how that fraction looks as well. If you cannot go down and right, you're going to say it's opposite. Instead of a -3, we're going to go up 3. and we're going to go left 1. Notice that only one part of your fraction is negative. So remember, if only one part of your fraction is negative, the whole slope is negative, so you have 2 options to go. We're going to start from our starting position, and we are going to go up 3, left 1. So start with me. We're going to rise 3, 1, 2, 3, left 1, put a dot right there. We're going to keep going because we need at least one more dot. So we're going to go up 3, 1, 2, 3, left 1, put a dot right there. Now notice, before you connect all of your dots, use the pencil test really quick. When you do the pencil test, are your dots going up or down? And is your slope negative? So we know we probably graphed it correctly since our dots go down and our slope is negative. Since we have at least 3 points, we're going to take our handy dandy ruler. We're going to place it on our little graph paper. We're going to line up the dots to our best of our ability. And we're going to connect them. Go ahead and connect all of those dots together. Ready? The best of your ability. Good job. Now, we're just graphing 3 dots, but what do we have to put at the end of our line? We're going to put arrows at the very end of our line to show that it does not end. We're just a little lazy. We're only going to graph 3 dots. But technically, this line doesn't end. Awesome. Okay. Now, I highly encourage you, especially for tomorrow, to make sure you're always checking with the pencil test. Remember, the pencil test is only good for slope. So the slope tells you if your line should trend up or down, if it should increase or decrease. Make sure it always goes up if it should increase. It always goes down if you should decrease. Okay? Awesome. All right. We're going to put this in Unit 3. We're going to keep it out, though, because I want you practicing this with this week's assignment. Okay? We're going to do AA7 as our assignment. Now, this one's really hard, but you have a benefit of myself and Miss Maddie. We can help you. So we're working on AA.7 now. And please ask me or myself for questions, and we're using our notes, okay?